Sometimes the innovators who challenge centuries of tradition are the ones who see possibilities where experts see only impossibility. The cold morning fog rolled across the Swan Island shipyard in Portland, Oregon, and Henry Kaiser wondered if today would finally be the day the old guard dismissed him entirely. Not with words or formal rejections. That would be too straightforward for an industry steeped in 3,000 years of tradition. No, they preferred the slow death of 1,000 sneers, each subtle dismissal designed to remind him that he was nothing more than a dam builder who had wandered into the wrong profession. He stood in the cavernous assembly bay, watching workers prepare sections of hull that would soon become vessels carrying the fate of nations. It was December 1940, and the world was burning. German U-boats prowled the Atlantic like wolves, sinking merchant vessels faster than Britain's traditional shipyards could replace them. Every week brought news of more ships lost, more supplies sent to the ocean floor, more sailors who would never come home. The British Empire was hemorrhaging its lifeblood across the cold waters, and Winston Churchill himself had confessed that the U-boat peril was the only thing that truly frightened him during the war. Kaiser pressed his rough hands against the cold steel of a hull section, feeling the weight of impossible expectations. 58 years old with no shipbuilding experience whatsoever. The established shipyards had laughed when they heard he'd won the contract to build 30 cargo ships for the desperate British. Little dam builder, they called him behind closed doors. A construction man who thinks he can teach the sea a new trick. The man who would build bridges when he should stay building dams. But Kaiser had learned something building the Hoover Dam, the Bonneville Dam, the Grand Coulee Dam, massive projects that had transformed the American West. He had learned that impossible was just another word for not yet attempted. He had learned that old ways could be questioned, that tradition was not the same as truth, and that sometimes the greatest innovations came from people who didn't know enough to understand why something couldn't be done. His entire career had been built on seeing obstacles as puzzles waiting to be solved, rather than barriers demanding retreat. The foreman approached, his weathered face showing the skepticism of a man who had spent 40 years building ships the right way. "Mr. Kaiser, the men are asking again about your welding idea. They say it's madness. They say ships have been riveted for centuries because riveting works. They say welding will make the hulls weak, that the ships will crack and split under stress. They say you're going to get good sailors killed with your fancy construction tricks. They're talking about walking off the job if we proceed." Kaiser turned to face the foreman, and for a moment all the doubt threatened to overwhelm him. What if they were right? What if his ignorance of shipbuilding tradition was not an advantage but a fatal flaw? What if his assembly line thinking, his modular construction dreams, his welding revolution was nothing more than the dangerous fantasy of a man who didn't know better? The weight of potential failure pressed down on him like the cold morning fog pressing down on the shipyard. "Tell the men," Kaiser said quietly, his voice carrying the steel he'd learned to forge in crucibles far from the ocean, that tradition built every ship that now rests at the bottom of the Atlantic. "Tell them that the British are losing vessels so fast they'll have no merchant fleet left by summer. Tell them that if we build ships the old way, at the old pace, we might as well hand victory to Hitler on a silver platter. Tell them that yes, I'm ignorant of shipbuilding tradition, and that ignorance might be exactly what we need. Tell them I'm willing to stake my reputation, my fortune, and my name on methods they've never seen before." The truth was more complicated than Kaiser's brave words suggested. He wasn't completely ignorant. He had partnered with Joseph Todd of Todd Shipyards, a man who understood ship construction intimately. Todd brought decades of maritime knowledge, understanding of naval architecture, awareness of ocean stresses and material requirements. But Todd brought knowledge of how things had always been done. Kaiser brought revolution, the willingness to question every assumption, to challenge every tradition, to ask why at every turn. And revolution was what the desperate times demanded. Traditional shipbuilding was a craft, almost an art form passed down through generations. Ships were constructed from the keel up, piece by painstaking piece, with hundreds of workers swarming over a single vessel for months. Steel plates were positioned precisely. Holes were drilled through overlapping edges with exacting tolerances, and tens of thousands of rivets were heated until they glowed orange, then driven through the holes by teams of skilled riveters working in perfect synchronization. The work was loud, dangerous, hot, and achingly slow. A single Liberty ship design, if built using traditional methods, would require 6 months of continuous work. The British ship Dorrington Court, similar in design to what would become the Liberty ship, had taken 8 months to complete using conventional riveting techniques in British yards. And Britain needed not 6 ships or 60 ships, but hundreds, immediately. Yesterday. Last month. The mathematics of survival were brutal and unforgiving. German U-boats were sinking Allied merchant vessels at a rate of approximately 60 ships per month at their peak. Each vessel lost represented not just tons of steel and machinery, but food that would never reach hungry civilians, ammunition that would never reach soldiers fighting fascism, fuel that would never power tanks or aircraft, medical supplies that would never heal the wounded. Every ship on the ocean floor was a small victory for Adolf Hitler and his vision of a world under totalitarian darkness. Kaiser's mind worked differently than traditional shipbuilders. He thought like a construction engineer, like someone who had coordinated massive projects involving thousands of workers and millions of tons of material across vast distances and impossible deadlines. When he looked at a ship, he didn't see a craft to be lovingly assembled by master artisans over many months. He saw a product to be manufactured efficiently, a problem to be solved through modern industrial methods. And manufacturing, he knew from his dam-building experience, could be revolutionized through systematic thinking and willingness to abandon outdated practices. The key insight was prefabrication, a concept that seemed obvious in retrospect, but revolutionary in application. Why build a ship entirely on one slip, one piece at a time, with workers waiting for previous tasks to be completed before beginning the next? Why not build entire sections simultaneously in different parts of the shipyard, then bring those massive sections together and join them? It was how he'd built dams, coordinating work on different sections of massive structures at the same time. It was how Henry Ford built automobiles, revolutionary assembly lines that had transformed American manufacturing. It was how modern construction achieved the impossible on impossible timelines. Build the bow section here with one crew, the stern section there with another crew, the deck section somewhere else entirely with a third crew. Build them on their sides when necessary to make welding easier, upside down if it made the work more efficient. Then bring them together with massive cranes and join them into a complete vessel in days rather than months. But joining prefabricated sections meant welding on a scale never before attempted in shipbuilding. And welding meant challenging 3,000 years of maritime tradition, questioning the accumulated wisdom of countless generations of shipwrights, defying the established order of an industry that viewed change with deep suspicion. A visit by one of Kaiser's associates to a Ford assembly plant in Detroit had crystallized the idea and demonstrated its feasibility. Ford didn't rivet cars together, painstakingly drilling holes and driving rivets through overlapping metal pieces. They welded components, using techniques that were faster, required less skill to learn, and created smooth, strong joins without the weight penalty of thousands of rivets. Ford had revolutionized automobile manufacturing, transforming it from a craft industry producing expensive vehicles for the wealthy into a mass manufacturing enterprise, producing affordable transportation for millions. Why couldn't the same principles revolutionize shipbuilding? The objections from traditional shipbuilders were immediate, fierce, and seemingly overwhelming. Welding was untested at the scale of ocean-going vessels. Welding created continuous seams that could propagate cracks catastrophically, unlike riveted seams that could stop crack growth. Welding required different grades of steel with specific properties. Welding introduced hydrogen into steel that could cause embrittlement. Welding created heat-affected zones with altered material properties. Welding was fine for automobiles and small vessels, but a 441-foot cargo ship weighing 14,000 tons and designed to cross the Atlantic Ocean in winter storms. Madness. Suicidal. Irresponsible. The work of a man who didn't understand that the ocean was an unforgiving teacher and that shortcuts led to graves on the seabed. Kaiser listened to every objection with the patience he'd learned managing contentious dam projects. He took notes. He asked questions. He consulted with metallurgists and naval architects. Then he proceeded anyway, convinced that the objections, while rooted in genuine concerns, represented an industry too wedded to traditional methods to see the necessity of radical change. His reasoning was practical, bordering on brutal. Welding was faster than riveting, much faster. A skilled rivet team required a heater who heated rivets until they glowed, a catcher who caught the hot rivet and placed it in the hole, a bucker who held a heavy backing plate, and a riveter who drove the rivet home with a pneumatic hammer, all working in synchronized rhythm that required years of experience to perfect. Such a team might install perhaps 1,500 rivets per day if they were highly skilled and experienced. Welding could be learned by relatively unskilled workers in weeks rather than years. A competent welder could complete linear feet of seam per day that would have taken rivet teams much longer. Welding didn't require the same upper body strength as swinging a rivet hammer for hours, which meant women could do it effectively. And women would have to do it, because able-bodied men were being drafted into military service by the thousands every week. Moreover, welding had advantages beyond just speed of construction. Welded ships were lighter by approximately 300 tons compared to riveted vessels of similar size and carrying capacity. That weight savings translated directly into additional cargo capacity, meaning each ship could carry more supplies, more ammunition, more food, more fuel to the theatres of war. Welded seams were smoother, creating less drag through water and marginally improving fuel efficiency. And welding eliminated the thousands upon thousands of holes drilled through steel plate for rivets, holes that were potential weak points, and sources of leaks that required constant maintenance. But Kaiser's revolution went far deeper than just welding. He completely reimagined the entire shipbuilding process itself, applying lessons learned from managing the construction of massive dams to the challenge of building ships at unprecedented speed. In traditional shipyards, a ship was started on a building slip and then remained in that one place until it was finished. Workers came to the ship, tools came to the ship, materials came to the ship, cranes brought steel plate to the ship, riveters swarmed over the slowly growing hull. Everything converged on one slowly growing hull that monopolized a precious building slip for months, preventing that slip from being used to start another vessel. Kaiser reversed the entire equation through systematic application of modern manufacturing principles. Instead of bringing everything to the ship, he brought the ship to everything. His radical concept involved building more than 30,000 components per ship in factories scattered across the entire country. From machine shops in the Midwest to steel mills in Pennsylvania, from engine manufacturers in California to valve makers in small towns nobody had ever heard of. These components flowed to the shipyards by rail, arriving on precise schedules coordinated across continental distances, a logistics achievement that rivaled the ship construction itself in complexity. At the shipyard itself, Kaiser divided the construction process into massive modules that could be built simultaneously. Entire deckhouses, the structures where the crew lived and worked, would be assembled complete in separate areas of the yard, with interior fittings, piping, electrical wiring, and fixtures all installed while the module sat on land where workers could access it easily. Then the complete deckhouse would be lifted by crane as a single unit weighing dozens of tons and placed onto the ship in one operation. Double bottom sections, the complex structures that formed the hull bottom and provided protection against torpedoes, stern frame assemblies that held the propeller and rudder, bow units that would cut through Atlantic waves, bulkheads that divided the interior into watertight compartments, all constructed separately and then brought together in a final assembly operation that took days rather than months. The skeptics had a field day with Kaiser's methods, and their criticisms filled shipbuilding trade journals and industry meetings. This isn't how ships are built, the traditionalists insisted with the certainty of people who had never seriously questioned their own methods. You can't treat a seagoing vessel designed to survive Atlantic storms like a child's building blocks that snap together. Ships require precision, craftsmanship, attention to detail that takes years to learn. The ocean will find every weakness in your hurried construction. Your ignorance will kill men. Your hubris will send good sailors to the bottom. Your methods are an insult to everyone who has ever built a proper vessel. Kaiser's response was to hire the skeptics when he could, paying premium wages that drew experienced workers from traditional yards. He brought in knowledgeable ship workers wherever he could find them, offering salaries above industry standards and working conditions that emphasized safety and efficiency. He established comprehensive training programs that could take someone who had never seen a ship under construction and turn them into a competent welder in 6 to 8 weeks through intensive instruction and supervised practice. He hired women at unprecedented rates for heavy industry, recognizing that gender had absolutely nothing to do with the ability to run a welding torch competently or operate assembly equipment effectively. He hired African Americans in numbers that shocked the establishment, creating one of the most integrated industrial workforces in America at a time when segregation was still legal throughout much of the country. The social implications of Kaiser's hiring practices were profound and far-reaching, though often overlooked in the focus on his technical innovations. In Richmond, California, where he established his largest shipyard complex, thousands of African American workers migrated from across the country, seeking good-paying jobs in an industry that had traditionally excluded them based solely on race. When local officials, resistant to this dramatic demographic shift and operating under openly racist attitudes, refused to build adequate housing for black workers, Kaiser built housing himself. He established childcare facilities at the shipyards, so women with children could work without worrying about their children's safety and care. He created a comprehensive healthcare system for his workers that would eventually become Kaiser Permanente, one of the largest health maintenance organizations in America. His yards became models of what integrated workforces could achieve when given opportunity and proper support. But in December 1940, as Kaiser stood in that cold assembly bay watching workers prepare the components that would become the first ships, none of the future success was certain or even likely. He had a contract demanding 30 ships for the desperate British. He had a vision that most experts said was impossible or suicidal. He had methods that had never been proven at this scale, and he had a ticking clock, measuring time in sunken ships and drowned sailors. The first Liberty ship, designated EC-2SC-1 by the Maritime Commission, but named SS Patrick Henry after the Revolutionary War patriot whose famous speech, "Give me liberty or give me death," would inspire the entire class of vessels, would be a test of everything Kaiser believed about modern shipbuilding methods. President Franklin Roosevelt himself would attend the launching ceremony in September 1941 at the Bethlehem Fairfield Shipyard in Baltimore, Maryland. Roosevelt, who loved ships and had served as Assistant Secretary of the Navy, examining the blueprints with a knowledgeable eye, would famously remark that the ship would carry a good load but wasn't much to look at. He would call it a real ugly duckling. The name stuck. The Liberty ships became known as ugly ducklings, vessels built for utility rather than beauty, for speed of construction rather than elegance of line, for function rather than form. That first ship took 244 days from keel laying to launch. Not fast by the standards that would develop later, but remarkably quick for a first attempt using entirely new methods, new workers, new techniques, new everything. And then the real learning began, the systematic refinement that would transform shipbuilding. Kaiser and his workers and engineers refined the process with every ship they built. They identified bottlenecks where work piled up and eliminated them through better scheduling and resource allocation. They improved welding techniques and welding sequences to minimize distortion and improve strength. They optimized the flow of materials through the yard and improved the positioning of workstations to reduce wasted motion. They invented new tools specifically for their methods and developed new techniques for handling massive components. A worker at the Richmond Yard devised what became known as the Little Prefab Plant, where crews prefabricated and assembled precision-cut plates that formed the foundation of Liberty ship steam engines, trimming the time needed for final installation by almost 90% through clever engineering. Suggestions poured in from workers at all levels, and Kaiser actively encouraged this grassroots innovation. Unlike many industrialists of his era who viewed workers as interchangeable labor units, Kaiser recognized that the people actually doing the work often had the best ideas for improving it. The Maritime Commission received more than 3,000 improvement suggestions during the war years from Kaiser's yards and others, which collectively saved approximately $45 million and 31 million labor hours. The respect Kaiser showed his workers by listening to their ideas and implementing the good ones was returned in innovation, dedication, and loyalty. The construction time dropped dramatically as experience accumulated and improvements compounded. By early 1942, just months after the first ship's launch, Kaiser's yards were completing ships in an average of 197 days, cutting the time nearly in half. By the end of that year, with America now fully engaged in the war following Pearl Harbor, the average time had fallen to approximately 70 days. By 1943, with workers experienced and methods refined, the average construction time was under 50 days, a staggering improvement that would have been dismissed as impossible fantasy just 2 years earlier. The labor hours required per ship dropped from approximately 640,000 in March 1941 to approximately 352,000 by early 1943, an efficiency improvement of nearly 50%. In the most efficient Kaiser yards, construction time for regular production vessels approached 35 days. Then came the publicity stunt that would make Henry Kaiser a household name across America and transform him from controversial industrialist into national hero. In November 1942, to demonstrate the full potential of his methods, and boost public morale during dark days when American forces were suffering defeats in both the Atlantic and Pacific. Kaiser staged a carefully orchestrated competition among his various yards. The winner, using prefabricated sections that had been prepared over many days prior, assembled the SS Robert E. Peary from Kiel, laying to launch in 4 days, 15 hours, and 29 minutes of continuous work. It was a theatrical achievement rather than a practical production method, and much fitting-out work, installing equipment, and completing the vessel for sea remained after the dramatic launch. But the publicity value was immense and immediate. Newsreels showed the impossibly fast construction. Newspapers ran stories with headlines marveling at the speed. Kaiser became a national hero overnight, the man who was building ships faster than Germany could sink them, the industrial wizard turning American manufacturing might into a weapon that would help win the war. The establishment's response to Kaiser's dramatic success was decidedly mixed. Some traditional shipbuilders, recognizing that the war's extraordinary demands made old ways obsolete, adopted his methods or variations of them. Others, having invested decades in traditional skills and traditional equipment, clung to their skepticism, waiting for Kaiser's revolution to fail spectacularly and vindicate their warnings. The failure, when it came, exceeded their worst predictions. The winter of 1942 to 1943 brought disaster that threatened the entire Liberty ship program. Liberty ships began cracking, not minor surface cracks but massive structural fractures that split hulls and decks. On January 16, 1943, in an incident that sent shock waves through the shipbuilding industry, the SS Schenectady, a two-tanker that was actually Kaiser's very first ship from his new Portland yard, split completely in half while docked in calm water. The ship had just completed sea trials successfully and returned to port. Without warning, and with a report that was heard for at least a mile, the deck and side shells of the vessel fractured just aft of the bridge superstructure. The fracture extended almost instantaneously through the deck, the side shell, the longitudinal bulkheads, and the bottom girders. Only the bottom plating held the bow and stern sections together, preventing the ship from falling apart completely. The vessel jackknifed grotesquely, the center portion rising out of the water, while the bow and stern settled into the river bottom silt. The explosion of that failure echoed through the shipbuilding industry, the government, the press, and public consciousness. Kaiser's critics erupted in vindication that bordered on celebration. "We told you so," they proclaimed with barely concealed satisfaction. "You can't cheat tradition. You can't replace 3,000 years of accumulated knowledge with assembly line tricks invented by a man who built dams. Welding doesn't work for ships. Your workers are untrained and incompetent. Your methods are unsound and dangerous. These ships are death traps. Shut down the program immediately before more sailors die from your arrogance." The criticisms intensified when more failures followed in rapid succession. In March 1943, the SO Manhattan, a commercial tanker, split in half while entering New York Harbor, creating a maritime emergency in one of the world's busiest ports. Ships were failing in the open ocean too, often catastrophically and with loss of life. The SS John P. Gaines, launched in July 1943 from the Oregon Shipbuilding Corporation, fractured completely in half in November while sailing from Dutch Harbor in the Aleutian Islands to Seattle. The vessel broke in two as air temperatures hovered around 0 degrees Celsius and a large swell washed over the bow, the combined stresses exceeding what the hull could withstand. 10 crew members died when the bow section sank almost immediately, while the stern section drifted until running aground in Alaska, where survivors were eventually rescued. Statistics painted an increasingly grim picture that seemed to validate every warning the traditional shipbuilders had issued. By January 1943, approximately 20 ship failures had occurred, with 4 or 5 suffering what was classified as Class 1 damage, meaning total hull failure, catastrophic structural damage, or loss of the vessel. 20 Class 1 failures occurred in January 1944 alone. 120 failures of various severities occurred in March 1944. Nearly 1,500 instances of significant brittle fractures were ultimately recorded across the entire Liberty ship program, an alarming failure rate that suggested fundamental flaws. 12 vessels, including 3 of the 2,710 Liberty ships eventually built, broke completely in half without warning, catastrophic failures that killed crew and raised serious questions about the entire program. The pressure on Kaiser was immense and unrelenting from multiple directions. Official investigations focused intensely on his yards, his revolutionary methods, his welding techniques, his use of relatively untrained workers. Congressional committees demanded detailed answers and threatened to shut down the program entirely. The press, which had lionized Kaiser as an industrial hero just months earlier, now questioned whether he was a charlatan whose dangerous shortcuts were killing brave merchant mariners who were already facing extraordinary dangers. The criticism was particularly painful because merchant marine service during World War II was extraordinarily and disproportionately dangerous compared to other forms of war service. 1 in 26 merchant mariners died during the war, a fatality rate higher than any branch of the armed forces. Were Kaiser's supposedly revolutionary ships making that terrible toll even worse? Were sailors dying not just from enemy action but from structural failures that could have been prevented by using traditional methods? Kaiser could have retreated at this point. He could have abandoned welding and returned to traditional riveting that the critics insisted was proven and reliable. He could have slowed production dramatically and adopted more conservative methods that emphasized traditional craftsmanship over speed. He could have let the establishment win, accepting that his revolution had failed. Many businessmen would have done exactly that, protecting their reputation by backing away from controversial methods. Instead, Kaiser fought back with science, supporting comprehensive investigation rather than defensively refusing to examine the failures. The United States Coast Guard, which held legal responsibility for merchant vessel safety, established a board of investigation into the construction, design, and fracture of welded ships in April 1943. The British Ministry of War Transport, facing similar failures in British-built welded vessels, borrowed a ship specifically for destructive testing. The Empire Duke, conducting experiments that would help understand the failure mechanisms. Scientists and engineers from universities, government laboratories, and private industry began systematic investigation of the failures, trying to understand the underlying causes rather than simply blaming welding or Kaiser's methods. The breakthrough that saved the program and revolutionized materials science came from an unexpected source and challenged everyone's assumptions about what was actually failing. Constance Tipper, a metallurgist at Cambridge University in England, demonstrated conclusively through careful scientific investigation that the fractures were not starting in the welds themselves as everyone had assumed. The welds were structurally sound. The welding technique, while it could be improved, was not the fundamental cause of failure. The problem was the steel itself, the base material from which the ships were constructed. Tipper discovered something that would revolutionize materials science, structural engineering, and ship design for generations to come. The ductile to brittle transition temperature. Steel, normally a tough and ductile material that bends and deforms substantially before breaking, undergoes a dramatic and dangerous change in behavior at low temperatures. Above a critical temperature that varies with the steel's composition and microstructure, steel behaves in a ductile manner, absorbing energy through deformation and giving clear warning before failure. Below that critical temperature, the same steel that is tough and resilient becomes brittle and prone to catastrophic fracture, with little or no warning. A crack that would normally grow slowly in ductile steel, giving visible warning signs and allowing time for repair, could propagate almost instantaneously through brittle steel at supersonic speeds, splitting a ship in half in seconds. The Liberty ships were built using steel that had an unfortunate ductile to brittle transition temperature around 40 degrees Celsius, well above the temperatures encountered in cold ocean environment. Ships operating in the frigid North Atlantic, where water temperatures hover near freezing and air temperatures routinely plunge well below 0 Celsius, were effectively sailing with hulls made of brittle material rather than tough steel. One crack, initiated at a stress concentration point, like a square corner on a cargo hatch or at a welding defect, could race through the entire structure faster than sound, splitting the vessel catastrophically before anyone could react or even understand what was happening. This fundamental materials problem was compounded by design issues that were unrelated to welding but made the consequences worse. The Liberty ships, designed rapidly under wartime pressure, had square corners on their cargo hatches. These 90-degree corners, while necessary for practical cargo loading operations and maximizing usable space, created severe stress concentration points where forces accumulated dramatically. In naval architecture, sharp corners act as stress multipliers, concentrating forces that would otherwise be distributed more evenly. In a riveted ship built with traditional methods, a crack reaching a riveted seam would typically stop, at least temporarily, because the rivet line created a structural discontinuity that interrupted crack propagation. Individual rivets could fail, but the crack would have to effectively restart at each rivet, slowing or stopping its growth. In a welded ship with continuous seams, nothing interrupted crack propagation. A crack could race unimpeded through the uniform structure, limited only by the speed of sound in steel. The welding itself did contribute to some problems, though it was not the primary cause, critics claimed. Unskilled welders rushed through training programs designed to create competent workers in weeks rather than the years traditional training required. Sometimes created welds with microscopic flaws, cracks, or incomplete fusion. Welding also introduced hydrogen into the steel from moisture in welding electrodes or atmospheric humidity, causing a phenomenon called hydrogen embrittlement that made the material more susceptible to cracking. Improper welding sequences could create locked-in residual stresses as different sections cooled and contracted at different rates. But comprehensive analysis showed these were secondary factors. The primary cause was steel selection combined with stress concentration design issues, failures of materials science understanding and structural design, rather than failures of Kaiser's revolutionary construction methods. 2 years after the war ended, an official board of investigation completed comprehensive analysis and determined that faulty workmanship, meaning welding defects and construction errors, caused exactly 25% of the 2,504 fractures that had occurred through August 1, 1945. A combination of inferior workmanship and inadequate design, where poor execution exacerbated design weaknesses, caused another 20%. But design so poor that even perfect workmanship would have done little to prevent the failures caused a stunning 55%. In other words, the majority of failures resulted from fundamental design decisions, particularly steel selection and stress concentration issues, rather than Kaiser's revolutionary construction methods or welding itself. The solutions came in systematic waves as understanding improved. Ship designs were modified to round off the problematic square hatch corners, eliminating or reducing the worst stress concentration points through relatively simple geometry changes. Riveted crack arrestor straps were retrofitted to existing Liberty ships and incorporated into new construction, running the length of hulls to create structural discontinuities that would stop or slow propagating cracks. New specifications for steel were developed and implemented, requiring significantly better fracture toughness at lower temperatures through improved composition and heat treatment. Welding procedures were systematically refined and quality control dramatically improved through better training, certification programs, and inspection procedures. Ships were routed through warmer waters when tactically possible, avoiding the coldest regions where brittle fracture was most likely, a logistical adjustment that provided immediate risk reduction. And critically, the program continued operating and even expanding because the fundamental truth remained unchanged. Kaiser's methods worked and were absolutely essential to the war effort. They worked spectacularly well. The modified Liberty ships, incorporating lessons learned from the failures and built with improved steel and design changes, proved remarkably durable, safe, and reliable. Of the 2,710 Liberty ships ultimately built, only approximately 200 were lost to all causes during the war, a loss rate of roughly 7%. Many of those losses resulted from enemy action, submarine attacks, mines, kamikaze strikes, and naval battles, rather than structural failure. The Liberty ships, ugly ducklings though they were, performed their mission superbly. The production statistics were staggering and unprecedented in shipbuilding history. 18 American shipyards, many using Kaiser's methods or variations inspired by them, built 2,710 Liberty ships between 1941 and 1945. That represents an average of 3 ships completed every 2 days for 4 continuous years, a production rate that defied imagination. Kaiser's 7 shipyards alone built 821 Liberty ships and 219 Victory ships, a slightly improved design introduced in 1944. Kaiser's yards accounted for approximately 27% of all wartime maritime commission shipbuilding, an astonishing market share for a man who had never built ships before 1940. Each Liberty ship could carry approximately 9,000 tons of cargo in its holds, plus additional tanks, aircraft, vehicles or other equipment loaded on deck. A single vessel could transport 2,840 jeeps, 440 tanks, or 230 million rounds of rifle ammunition across an ocean. The ships carried the tools of war to every theatre of combat. Europe, Africa, the Pacific, the Mediterranean, the China-Burma-India theatre. They transported not just military cargo, but the fuel that powered Allied armies, the food that fed Allied soldiers and civilians, the ammunition that armed resistance, the medical supplies that saved lives. and most crucially, hope that fascism could be defeated. Without the Liberty ships and the revolutionary methods that made their mass production possible, the Allied victory would have been delayed by years, perhaps made impossible. The Battle of the Atlantic, which Churchill feared above all else, was won not through any single dramatic naval engagement, but through the grinding mathematics of production versus destruction. German U-boats sank Allied merchant vessels at horrific rates, but American shipyards, led by Kaiser's innovations, built replacements faster than the Germans could sink them. By mid-1943, the tide had decisively turned. New ships entered service faster than losses occurred, the maritime lifeline strengthened rather than weakened, and the strategic balance shifted irreversibly toward the Allies. Kaiser's revolution extended far beyond the Liberty ships themselves and transformed American industry. His methods fundamentally changed shipbuilding from a craft-based traditional industry into a modern manufacturing enterprise. The techniques of prefabrication, modular construction, and assembly line production became standard practice not just in American shipbuilding but globally, remaining fundamental to shipbuilding today. The Japanese and South Koreans, rebuilding their devastated shipbuilding industries after the war with American assistance and advice, studied Kaiser's methods carefully and adopted them comprehensively, laying the foundation for shipbuilding industries that would eventually dominate global commercial shipbuilding markets. The lessons in materials science and fracture mechanics from the Liberty ship failures proved equally valuable to engineering progress. The understanding of ductile to brittle transition temperature, stress concentrations, fracture mechanics principles, and crack propagation became fundamental concepts taught to every structural engineer and materials scientist. New types of steel were developed with vastly superior fracture toughness across wider temperature ranges. Design practices evolved to systematically avoid sharp corners and stress concentrators. Welding techniques improved dramatically through research into metallurgy, heat-affected zones, and residual stresses. Modern ships and structures are designed with comprehensive understanding of these principles, making catastrophic structural failures from brittle fracture extremely rare in properly designed and maintained vessels. But perhaps Kaiser's most important and lasting legacy was demonstrating that innovation often requires productive ignorance of conventional wisdom. The established shipbuilders, experts with decades of experience, knew too much about why revolutionary changes couldn't work. They could list dozens of reasons why prefabrication was impractical, why welding was unsuitable, why assembly line methods wouldn't work for complex vessels. Kaiser, approaching shipbuilding as an outsider without preconceptions or emotional attachment to traditional methods, didn't know enough to be deterred by supposed impossibility. He saw a problem requiring solution, applied fresh systematic thinking unencumbered by tradition, and created approaches that experts had never seriously considered. This isn't to say that expertise doesn't matter or that ignorance alone accomplishes anything valuable. Kaiser partnered extensively with genuine experts, hired experienced workers wherever possible, learned voraciously from failures and successes, and refined his methods based on systematic feedback and rigorous analysis. Ignorance alone accomplishes nothing productive, but productive ignorance, the state of not knowing what supposedly can't be done, combined with intelligence, determination, systematic learning, and willingness to adapt based on evidence, can achieve what hidebound expertise never attempts, because experts know too well why it's impossible. The establishment's response to Kaiser's ultimate vindication was grudging but eventually genuine. By 1944, even his harshest critics acknowledged that his methods had proven successful beyond reasonable dispute. The Maritime Commission awarded him additional contracts for more advanced vessels. Other shipbuilders adopted his techniques wholesale or developed variations inspired by his innovations. The government recognized his contributions as absolutely essential to the war effort. He became, for a time, one of the most celebrated industrialists in America, featured in newsreels, profiled in magazines, praised by presidents. Kaiser himself remained remarkably humble about his achievements, considering his reputation for promotional flair. In public statements throughout and after the war, he consistently praised his workers. The ordinary Americans who learned new skills, worked long, grueling hours under difficult conditions, and ultimately built the ships that helped win the war. He credited the Maritime Commission for supporting innovation despite risks. He acknowledged the scientists and engineers who solved the steel and fracture problems that threatened the program. He recognized that success was fundamentally a collective achievement rather than individual genius, the product of thousands of people working toward common purpose. After the war, many Liberty ships were sold to private companies, and used profitably for commercial shipping, proving their durability far exceeded the pessimistic predictions. Others were scrapped for their steel or converted for different purposes as military needs changed. A few were preserved as museum ships, floating reminders of the largest single class of ships ever built, and the unprecedented industrial mobilization that made them possible. 2 Liberty ships remain operational today, the SS Jeremiah O'Brien in San Francisco and the SS John W. Brown in Baltimore. These lovingly maintained vessels serve as living museums, occasionally taking to sea with volunteer crews to demonstrate what the ugly ducklings could do and to honor the merchant mariners who sailed them into danger. The Victory ships that succeeded the Liberty ships, starting in 1944, incorporated all the lessons learned from the earlier program. They were slightly larger at over 450 feet long, significantly faster with modern steam turbines instead of the Liberty ship's old-fashioned reciprocating engines, built with better steel, specifically selected for superior fracture toughness, and designed with meticulous attention to avoiding stress concentrations. 531 Victory ships were built between 1944 and 1946, representing the mature evolution of Kaiser's revolutionary methods refined through hard-won experience. Kaiser himself moved energetically into other ventures after the war, with characteristic entrepreneurial drive. He formed Kaiser Aluminum, which became a major aluminum producer. He established Kaiser Steel, building an integrated steel mill that supplied West Coast manufacturing. He expanded Kaiser Permanente from a shipyard health plan into a pioneering national healthcare organization that still serves millions. He entered automobile manufacturing with Kaiser Frazer and later Kaiser Motors, producing vehicles known for innovative safety features before eventually exiting the car business. He remained active in construction, real estate development, and even television broadcasting with Kaiser Broadcasting. But he would always be remembered primarily, and most importantly, as the man who revolutionized shipbuilding when the world most desperately needed revolution. The story of Henry Kaiser and the Liberty ships is ultimately an inspiring story about courage in the face of withering criticism, innovation against supposedly impossible odds, and the transformative power of fresh thinking applied to seemingly intractable problems. It's a story about how one man's productive ignorance of traditional methods and willingness to question every assumption became his greatest strength, how assembly line manufacturing thinking transformed an ancient maritime craft, how welding decisively replaced riveting despite 3,000 years of tradition insisting otherwise. It's also importantly a story about failure, learning, and recovery. The Liberty ship cracks and catastrophic fractures were not minor setbacks or temporary problems. They were genuinely catastrophic failures that cost lives, threatened the entire program, and could easily have destroyed Kaiser's reputation permanently. Kaiser could have been ruined by those failures, dismissed as a dangerous amateur whose arrogance killed sailors. Instead, he faced the failures honestly without defensiveness, supported comprehensive scientific investigation rather than covering up problems, implemented systematic improvements based on evidence, and emerged substantially stronger, with methods proven sound through rigorous testing. The Liberty ships symbolize American industrial might during World War II, but they also symbolize something more profound and universally applicable: the willingness to attempt the seemingly impossible when necessity demands bold action. In December 1940, with Britain facing potential defeat and the Atlantic Ocean becoming a vast graveyard for merchant shipping, traditional methods were demonstrably insufficient. The old ways, honored and proven though they were through centuries of use, simply could not meet the unprecedented crisis. Innovation was not a luxury to be considered cautiously, but a survival requirement demanding immediate implementation despite risks. Kaiser provided that desperately needed innovation, but he couldn't possibly have succeeded without the contributions of thousands of others. The workers who learned welding and worked grueling shifts, the engineers who solved countless technical problems, the scientists who understood fracture mechanics and materials science, the government officials who supported unproven methods despite political risks, the merchant mariners who sailed the ships despite knowing the dangers from both enemies and potential structural failure. The Liberty ship program was fundamentally a collective achievement, demonstrating that when a democratic society mobilizes its full resources, creativity, and determination toward common purpose, it can accomplish feats that seem utterly impossible. Today, when we face our own seemingly impossible challenges requiring innovation and courage, the Liberty ships offer powerful and relevant lessons. Don't let conventional wisdom and expert opinion paralyze innovation when circumstances demand change. Learn systematically and quickly from failures, rather than being destroyed by them or covering them up. Value practical results and real-world performance over theoretical purity and traditional methods. Respect expertise and experience, but don't be unnecessarily constrained by claims of impossibility. Seek solutions from unexpected places and unconventional people who bring fresh perspectives. Move fast when circumstances demand speed, but adapt quickly and systematically when problems inevitably emerge. Support your people and acknowledge their contributions. And above all, remember that impossible is often just another word for not yet attempted by someone willing to question assumptions. Henry Kaiser stood in that cold assembly bay in December 1940, knowing he might fail spectacularly and publicly, knowing the critics were probably right that he didn't know enough about proper shipbuilding, knowing that his radical methods were untested at anywhere near this scale. But he also knew with absolute certainty that the world was burning in fascist flames, that desperate times demanded desperate measures regardless of risk, and that sometimes the only possible path forward is straight through the obstacles. 4 years later, with 2,710 Liberty ships launched and sailing, and the tide of war turned decisively and irreversibly in favor of the Allies, that cold morning's doubts and fears seemed like fading artifacts from another age. The dam builder who supposedly didn't know enough to build ships properly had built more ships than anyone else in human history, fundamentally transforming an ancient industry and helping save civilization itself in the process. The ugly ducklings proved beautiful after all, not in their physical appearance or elegant lines, but in their profound impact on history. They weren't designed to be elegant or sophisticated, or built to last for decades of peacetime service. They were designed and built to carry supplies across dangerous oceans during humanity's darkest hour of existential crisis, and they succeeded beyond anyone's reasonable expectations or hopeful dreams. Some broke catastrophically. Some failed and taught crucial lessons. But the vast majority sailed successfully and kept sailing reliably, delivering the goods that kept Allied armies fighting and free nations surviving. The traditionalists who initially mocked Kaiser as an ignorant dam builder who didn't belong in shipbuilding were right about one thing: he absolutely didn't build ships the way they did. He built them better, faster, cheaper, and in numbers that literally changed the course of history and determined civilization's survival. His supposedly stupid design, his allegedly ignorant methods, his supposedly untested welding techniques turned out to be exactly what the world needed, at exactly the moment it needed them most. Sometimes the wolves who howl the loudest about impossibility and tradition are simply the ones who fear what might happen if someone proves them wrong. And sometimes the supposedly stupidest design, the most ignorant approach, the most revolutionary method, is actually the one that works brilliantly when all the traditionally smart approaches fail to meet the challenge. The Liberty ships sailed. The Allies won. The world changed forever. And it all started with one man who didn't know enough to understand why it supposedly couldn't be done, standing in a cold assembly bay and deciding to attempt the impossible anyway, because there was simply no acceptable alternative.